At the end of this mini chapter, you should be able to name the two brain systems behind psychomotor syndromes such as catatonia. So let's think a little bit about the neurobiology of catatonia. The way we think about it really comes down to how we move and why we move. And at the end of the chapter, you will see that these two systems are connected. Let's start with thinking about the how we move by reviewing some of the basic motor systems. Imagine you see a friend walking towards you on the street and you decide to wave at your friend. The first question is what to move. And in order to answer this, let's actually look at the brain. You have the central sulcus right here. And then we got the primary motor cortex right here. And the primary motor cortex, once again, is responsible for what to move. Basically, it tells us which limb to move and where to. In our case, it might be the right or the left hand if you want to wave back at our friend. The next question is how much movement is needed. And here we got the basal ganglia involved. And you might remember from anatomy that there's a direct and indirect pathway. Do we need more or less movement, right? So how much movement? And then the last part is that we need to make sure that our movements are actually executed. And so we got the cerebellum, proportionally too small, but you get the gist. And the cerebellum is responsible for the execution of movements to make sure that they are precise and smooth. And if we are facing any issues with any of these three symptoms, like the primary motor cortex, the basal ganglia, or the cerebellum, we call our neurology colleagues. Example of diseases affecting these systems are Parkinson's disease or Huntington's disease and so on. The really interesting question though is what motivates us to move? Imagine instead of seeing our friend we want to wave to, we see something shiny like a diamond. Here symbolized through a star. If I can draw the star. And when we see something shiny like a diamond, something which gets us a gain like a reward, obviously we want to move. Of course, you would also like to move towards something else, like something which is threatening, something we would like to avoid. For our predecessors, this was something like seeing a lion. For North Carolinians, it is seeing a snake. I recently saw one. Or a car which is about to hit us. I moved down to Massachusetts before starting residency, and I thought Massachusetts drivers are ridiculous. But North Carolinian drivers showed me the opposite. Anyway, the motivation to move, the why do we want to move impulse, comes from the OFC, the orbitofrontal cortex. One way to remember the orbitofrontal cortex is that it is close to the orbital cavity, which houses our eyes, which make us see rewards and threats. And again, this pathway is responsible for what motivates us. Once we are motivated, we need to initiate our movements. The question is how do we start to move? This is what the ACC is responsible, the anterior cingulate cortex. Once again, it's the how do we start? And the anterior cingulate cortex might sound familiar to many of you. It has connections to both the emotional limbic system and the cognitive prefrontal cortex. As such, it plays a really important role and is pretty prominent in many psychopathologies, including OCD, depression, and other conditions. Lastly, we started our movements, and we at some point need to regulate our movements and need to stop them. And this is what the so-called SMA is responsible for, also called the supplemental motor area. And again, this one is responsible to regulate movements or to stop movements. Maybe one way to remember is, supplemental starts with an S, and you can think about like a stop sign because it's stopping our movements. And then you see the S again, the S and the S. Maybe that's one way of remembering it. So, in summary, we have a motivational system displayed here in green, the why do we want to move system, and the motor system displayed in red, the how we want to move system. These two systems are tightly connected, and if the motivational and the motor systems are not aligned through whatever process, medical process, a psychiatric process, then we do get psychomotor syndromes such as catatonia. And again, in this case, the how system works fine, the why system works fine, but it is really the connection between the how and the why system which does not work fine. And maybe you know this by listening to your patients when they tell you that they feel like they want to move, but they feel stuck. They feel like they want to talk, but they feel stuck. They feel like they want to interact. They're motivated to interact, but they feel stuck. In this mini chalk talk, we looked into the two brain systems behind psychomotor symptoms such as catatonia.